Hello, it's Mr. Yosef back at it with one more video. One thing I wanted to do, because I felt like I didn't do a lot of these examples in class, is evaluate the 6 trigonometric ratios using one of the quadrantal angles. So these are the angles that are on the actual coordinates. So this is 5 pi over 2. So I told you in class the way that you want to look at this is 5 times pi over 2. So if you think of pi over 2 as being 180 divided by 2, then you know that this is actually just 5 times 90 degrees, which is 450 degrees. So if I was going to make a quick graph, I know that if I go around once, that's 360. Keeps doing that. Or, before I do that, let me actually talk to you about this. So something interesting is, if you think about 360 degrees, we agree that this is 2 pi. But what about if we thought about 360 degrees in terms of halves? So would we agree that 360 degrees is equivalent to 4 pi over 2? So if I'm just adding pi over 2, that means I'm just going around once and then ending up here. And then when I end up here, this is the coordinate 0, 1, which again in class today, I don't know why I keep flipping it or doing something goofy, but let's talk about why it's 0, 1. We know that this is the line. We know that the radius is 1. And we know that our x value is 0. So the x value is 0 because, well, the x value is right here. And then we just went up 1. So our y value is 1. So we got 0, 1. So I told you on the unit circle, it might be useful to know a couple facts. So sine of theta equals y, cosine of theta equals x, tangent of theta equals opposite over adjacent, which is y over x, cosecant of theta equals 1 over y, or just a reciprocal of whatever you get for sine. Cosine, the reciprocal is secant, so 1 over x, and cotangent is x over y. So somebody in our class, I remember, said something about making a triangle if you like for 90 degrees. So if you want to think about it like this, if your x is 0, your 1 is y, and your hypotenuse is always 1, and this is our angle of focus, which we're saying is 5 pi over 2. We know that sine is technically just this value. So sine of 5 pi over 2 is just opposite over hypotenuse, or just your y coordinate, which is just 1. Cosine of 5 pi over 2 is your x coordinate, which is 0. Tangent of 5 pi over 2 is technically the opposite over adjacent, or if you think about this as being your y and this is your x, it's just 1 divided by 0, which is undefined. Then we get to secant, no, not secant, oops, cosecant. So one thing that might be useful is to go ahead and just put this over 1 and put this over 1, because technically here we're going to do the reciprocal, so we will get just a 1 here. The reciprocal of cosine is secant. So do you see here that you're actually going to get something that's undefined, because secant means hypotenuse over adjacent. Hypotenuse over adjacent, which means 1 over 0. And then my cotangent will actually be adjacent, which is 0, over hypotenuse, over opposite, which is 1, and we get 0. So that is how you would address something like this. Just to have some fun with this, let's go ahead and do coterminal angles. So if you have 5 pi over 2, coterminal angles just means rotating around another time and landing in the same spot. So if I wanted a positive coterminal angle, I would just add 2 pi. If I want a negative coterminal angle, I would just subtract. Put this over 1, put this over 1, multiply by 2, multiply by 2, multiply by 2, multiply by 2. and you get 5 pi over 2 plus 4 pi over 2, which is 9 pi over 2. And then here you would get 5 pi over 2 minus 4 pi over 2, which gets you pi over 2. So if we think about our visual again, if I do 9 pi over 2, that means that I have 9 pi over 2. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Land in the same spots. If I want to do pi over 2, I just go around once, land in the same spots. And that's pretty much it. Hope that helps.